Okay, so 11.2 is our learning goal here is I can find the area of a sector of a circle. So we'll talk about what a sector of a circle is. This actually, if you understood 11.1, like this section will be super easy for you. Just a quick review of area of a circle. So we know circumference we just did is 2 pi r. The area of a circle is pi times the radius squared. You guys have done that a bunch before. So A says the area of a circle with the radius of 2.5 centimeters. So I'm just going to go the area equals, right, pi times 2.5 squared. Okay, so you plug that in a calculator. By the way, 2.5 squared comes out to be 6.25. So I'm okay, you could leave the answer like this, 6.25 pi centimeters. Like that's great. Or you can plug it, that's the exact answer in terms of pi, or you can plug in a calculator and get an approximate. B says, what's the diameter of a circle with an area of 113.1 square centimeters? So now we're working backwards. We're going to go 113.1 equals pi times the radius squared. So let's solve for r, so divide by pi. The radius squared equals 113.1 divided by pi. Take the square root. Okay, and that would tell us what r is equal to. That's the exact answer, but if you want to get the approximate, right, plug that in a calculator. It's the square root of 113.1 divided by pi, and it comes out to be approximately 6. Not exactly, but approximately 6 is what it works out to be. And that would be labeled in centimeters. Oh, up here, I'm sorry. The area too should be square centimeters, right? We're talking about area now. The area is two-dimensional, so we measure it in square units. We're going to skip past that and this. Okay, we had these same two circles earlier, if you remember. I think on 11.1 we said this was 12 inches, I believe. So now what we're trying to do is find the area of a sector. So a sector is just a portion of a circle that's cut out by a central angle and an arc. So in this case, this would be the sector of the circle we're trying to find. Well, that's pretty easy, right? The area would just be pi r squared, so pi times 12 squared. That'd be the area of the entire circle, 144 pi square inches. If I want to find the sector that's out that I have outlined in red there, then that would just be half of that, right? So I'd go a half times 144 pi square inches. So 144 times a half, like half of 144 is that 72? So 72 pi square inches. That's the exact answer. You could plug that in a calculator and get an approximate. Right, if I look at this next one, this is, we said was 90. Let's say this is still 12 inches. I want to find the area of that sector. Okay, it's outlined in red right there. It's trying to find the area of this sector right here. Okay, so we know the area of the entire circle we already found was 144 pi. If this is 90 degrees, we go, the portion of the circle I'm trying to find is 90 out of 360, which reduces down to be a fourth. So I would times that by a fourth. 144 divided by 4, I'm pretty sure that comes out to be 36. So there'd be my answer right there. So when you think about this, is really the formula for finding the area of a sector is almost the same thing as finding the length of an arc, right? For the length of an arc, we found the circumference of the entire circle, and then we times it by the fraction or the portion of the circle we were trying to find. We got that by taking the angle over 360. So to do it with area, it's almost exactly the same. I take the measure of my angle over 360, and then I times it by the area, which in this case would do pi r squared to find that. That is the formula that you want to make sure you have written down. Okay, the measure of the angle divided by 360 times by the area itself, which is pi r squared. Make sure you pause that and copy that down. Okay, so let's find some areas. So we're going to find the area of this sector right here. Okay, so I tell you what portion of the circle I'm trying to find. That's a 70 over 360. We're going to times that by the area of the entire circle. The radius is 8, so pi times 8 squared. So I end up with, I can reduce this, so 7 over 336 times, I'm going to switch those around, times 64 times pi. Okay, we could actually reduce the 36 and the 64. I'm pretty sure 4 goes into both of those, right? So that'd be 9. 4 goes into 64 16 times. So if I wanted an exact answer, I would go 7 times 16. So 112 pi. And the bottom we just have 9. And this would be labeled in square inches. That's the exact answer. And then of course if we want an approximate, we would just plug that in a calculator. So 112 pi divided by 9 equals approximately 39.1 square inches. That's the approximate answer to that right there. Okay, so angle over 360 times by the area. Okay, that'll give us the area of the sector. You guys try this one. Let's do the area of the blue sector, just number 8. So pause this, work it out, and then we'll come back and check it with each other. So I've got to find the measure of that angle. Well, we know that that angle is let's see, here's 120. So if I go 360 minus 120, that comes out to be 240. So I'm going to go 240 over 360 times by the area, which is pi times the radius squared, so pi times 14 squared. I'm going to do a lot of reducing here. 24 over 36, you can divide both of those. Let's see what goes. Oh, my mind just went blank here. Let's see. 4 does, right? So divide them both by 4, so on top I'd have 6, on the bottom I'd have 9. Oh, so we divide both those by 3. So 2/3 is what that reduces. 2/3 times pi times 14 squared. So again, the exact answer, I would go 2 times 14 squared. That comes out to be 392 over 3 pi. Okay, that's the exact answer. And then we just plug in a count, and that would be, what's our label, square feet. And then we can label, if we want to find the approximate answer, I just plug that in a calculator, 392 times pi divided by 3. That comes out to be approximately 410.5 square feet. Okay, is the approximate solution. Let's just do one last problem. This one's working backwards. So this gives me, right, the area of this sector right here. It tells me the area is 35 meters. It tells me the angle is 40 degrees. It wants me to find the area of the entire triangle. So just plug all this in our formula. It's 40 over 360 times by the area has to equal 35. Well, this is the area. That's what I'm trying to find. So if I solve for that, I have my answer. So I'm going to reduce this. Zeros cancel out. 4 over 36 divided by 4, it comes out to be 1/9. I'm just going to call that the area. Okay, all I have to do now is times by 9, times by 9. Plug that in the calculator, and that gives me the area of the entire triangle. So 35 times 9 comes out to be 315, and we're labeled square meters. That's a little bit trickier just because it gives you, it doesn't ask you to find the area of the sector. It gives you the area of the sector and asks you to work backwards and find some more information. The last example I want to do is this number 10 right here. So this is a composite shape, right? We have a triangle and a half circle there. So let's see if we can figure this out. So the triangle, right, to find the area of that, that's just 1/2 the base times the height. Plus, and the area of the semicircle, that'd be 1/2 times pi r squared. So those are the two formulas I'm going to use. If it's a right triangle, then one side is the base and the other side is the height. So it'd be 1/2 times 7 times 7. Sorry, my board's wigging out a little bit there. Plus 1/2 times pi. Just be careful, 7 is not the radius, 7 is the diameter, so I need to cut that in half. So 3.5 squared. And I'm just going to find an approximate for this one, so I'm going to plug that whole thing in my calculator. So I'm going to go 1/2 times by 49 plus 1/2 times pi times 3.5 squared. Plug that whole thing in there and it comes out to be approximately 43.7 square meters. So again, if you get the finding length of an arc, the area of a sector is not too bad because the two formulas go together. The measure of the angle over 360. If it's length of an arc, you times that by the circumference. If it's the area of a sector, you times it by the area of the entire circle. Thanks, guys.